Welcome back to the deep dive. So, if you live somewhere like New England, really any place with that beautiful older American architecture, you know this problem. You love the character of, say, your 1890 farmhouse, but wow, that heating bill is just astronomical. Today, we're taking on a huge challenge, really. It's part engineering, part preservation. How do you bring a historic building into the 21st century of energy performance without, stripping away everything that makes it special? Our mission today is to break down the sources you sent us and give you a kind of blueprint for preserving and insulating these old houses the right way.
It's a really essential topic. And, the foundation for all of this, for all modern building science, it comes back to one simple truth that we just ignored for centuries. If your home was built before, let's say, the 1970s, and that's almost every historic home, it was designed to leak air, a lot of air, things like air barriers, air tightness. That just wasn't part of the conversation 50, 100 years ago.
Right.
And that leakage. That's why tackling the building envelope is the absolute cornerstone of any good retrofit.
Okay, and before we get any further, we have to just put one thing to rest right now. You've heard it, I've heard it. This idea that an old house needs to breathe. It sounds so wise and old-fashioned, but it is a complete myth.
A dangerous one, absolutely. Houses do not breathe, they leak.
Yeah.
That draft you feel on a cold day, that's uncontrolled air leakage. And it's the enemy of comfort, of savings, and, really importantly, the enemy of durability. The whole goal of modern building science is to get complete control. We want to decide where air comes in and where it goes out. The only breathing should be done by the people inside.
Right.
So if we think about a historic house as this very beautiful but very leaky balloon, the first step can't be just stuffing it with insulation. It has to be assessment. We have to figure precisely where the air is getting out and just how much leakage we're even dealing with. And here's the fascinating thing, the unseen danger. Uncontrolled airflow often creates what's called the stack effect.
Okay, what's that?
It's where warm air rises and escapes at the top of the house. And in doing so, it sucks replacement air in from the bottom. So you're literally pulling dusky, musty, damp air from your basement or your crawl space right up into your living areas.
So we need to find the leaks before we can do anything else. The sources we looked at called the professional energy audit, specifically something called the blower door test, the gold standard for this. What's actually happening during one of those tests?
Well, they come in and they install this huge high-pressure fan right into an exterior doorway. It's like a temporary airlock. They crank up the fan to depressurize the whole house, and what that does is it exaggerates every single tiny air leak.
So it makes the draft scream, basically.
Exactly. It gives the wind a really loud voice.
Mm-hmm.
Once those leaks are magnified, the auditors can go around with thermal cameras or smoke pencils and physically find them. But the real value is the number. You walk away with a piece of quantitative data that tells you exactly how leaky your house is. It gives you a target to aim for.
That quantitative piece is huge. But for, say, a DIY check, if you're just starting to think about this, the sources mention something anyone can do.
Oh yeah, the simple check. You just wait for a cold, windy day, light an incense stick, and walk around your house. Any place that smoke stream gets sucked away or blown sideways, that's a draft. Mark it with a piece of tape.
And where are you likely to find those? The usual suspects.
The usual suspects, absolutely. We pulled together a list. You're looking around window and door frames for sure. Any penetrations for plumbing or wiring. Attic hatches, those drop downstairs. And the surprising one-recessed lights and even ceiling fans. They can act like little chimneys for air.
Okay, so that brings us to what the sources call the envelope-first approach. The idea is you have to seal that shell of the home before you do anything else.
Exactly. And the best time to do it is during a big renovation, when the walls or the attic are already opened up. As for materials, it's pretty simple but crucial. For small cracks, up to a 1/4 inch, you're using a high-quality caulk. For the bigger, more irregular gaps, that's where spray foam comes in.
But there's a really important distinction there with the foam, isn't there? You can't just use any old can.
Oh, absolutely not. This is critical. If you are sealing around a window or a door frame, you must use low-expansion foam. It's usually labeled window and door foam. If you use high-expansion foam, it expands with so much force it can literally crush the frame and jam the window shut. It's a disaster.
Wow. Okay, so high expansion foam is for what then?
For bigger, less delicate areas, like where a pipe goes through a foundation wall or filling some weird irregular cavity in the attic, places where you need maximum fill.
So let's talk about the really cutting-edge solution, because this was fascinating. It kind of solves that whole problem of human error. It's called Aero Barrier Air Sealing Spray.
It is a total game changer. Like you said, it takes human diligence mostly out of the equation. Imagine the crew seals up all the big, obvious holes first. Then they pressurize the house, just like in the blower door test, forcing air out of every remaining pinhole. Then they spray a fine mist of a non-toxic acrylic adhesive into the space.
And it just finds the leaks on its own.
Pretty much.
Yeah.
As the air rushes out through a leak, it carries these tiny adhesive particles with it. They stick to the edges of the hole and build up on each other like a tiny beaver dam until the hole is sealed. It can seal openings up to an inch wide.
That is incredible. So instead of a person trying to find every single tiny hole with a caulk gun, you're basically turning the air pressure itself into a sealing machine. You can get to a level of airtightness you just couldn't achieve by hand.
It's a huge leap forward for retrofits.
Okay, so once that air envelope is tight, we move on to insulation. And this is where that conflict between preservation and performance really heats up, especially with solid masonry homes, the brick or stone houses you see all over the Northeast. We're told this is often the hardest and maybe least cost-effective part of the job, but you have to do it for a big drop in heat loss.
That's right. And this is where the stakes are highest, especially when it comes to moisture. If you insulate a solid wall incorrectly, you run a massive risk of something called interstitial condensation.
Okay, hold on. Let's unpack that. What is interstitial condensation in simple terms?
So, imagine you're wearing a thick wool sweater and you put a plastic raincoat over it on a cold day.
Go.
The moisture from your body goes through the sweater, hits the cold, non-breathable plastic, and turns back into liquid water. Your sweater gets soaked from the inside. That is exactly what happens inside a wall. Warm, humid air from inside your house moves into the wall, hits a cold surface, and condenses into liquid water inside the wall assembly. That leads to rot, mold, and it can destroy the historic fabric you were trying to save.
And that ties right back to that breathing myth. Those old buildings were designed to let moisture move in and out. If you slap modern, impermeable stuff on them, like vinyl wallpaper, you're basically putting that plastic raincoat on your house.
You're trapping the moisture. And it's not just wallpaper. We also have to talk about thermal mass. Solid stone or brick walls absorb heat and release it slowly, which helps stabilize the temperature inside. If you insulate on the outside, you keep that benefit. If you insulate on the inside, you cut the living space off from that thermal mass, and you lose that natural temperature buffer.
Okay, so let's break down the two main options for these solid walls. First, there's external wall insulation, or EWI.
EWI is, performance-wise, the better option. It keeps the original wall warm and dry, and you keep your thermal mass. But the heritage impact is huge. You are fundamentally changing the look of the building. Windows get these deep recessed eyebrows, the roof eaves look different. You will almost certainly need special planning permission for that.
And if you do it, you have to use the right materials, breathable ones like wood fiber boards with a lime render.
Yes, compatibility is everything. Which brings us to the other option, internal wall insulation, or IWI. This is what people choose when they have to preserve the exterior.
But this one carries the biggest risk, right?
By far. Because you're making the historic masonry wall colder, the risk of that condensation we talked about goes way up. For years, the solution was to put a plastic sheet, a vapor control layer, or VCL, on the warm side of the insulation to stop moisture from getting in.
But that sounds fragile.
Incredibly fragile. Think about it. One screw to hang a picture, one small tear during installation by an electrician.
And the barrier is broken.
And it's useless. And now you have moisture condensing behind your new wall where you can't see it for years. It's a technical time bomb.
So what's the better way?
The preservation world has moved toward what are called vapor open systems. These use materials like wood fiber board and lime plaster that don't block moisture. They manage it. They allow the wall to dry out naturally just like it was designed to. It eliminates the need for that risky plastic VCL entirely.
With all this complexity, the moisture risk, the material science, the preservation roles, this is clearly not a job for just any contractor.
Oh, absolutely not. The sources are clear on this. You need a multidisciplinary team, an architect, an engineer, and crucially, a heritage expert. They all have to be at the table from day one, planning this strategically.
And that plan starts with something called a heritage value assessment. That sounds a bit academic, but how does it help a homeowner?
It's basically an insurance policy for the building's soul. The assessment identifies the specific things, the original windows, the specific type of brick, the decorative trim, that are character-defining elements. Then, every single proposed change is measured against its impact on those elements. It forces you to have the tough conversations and make compromises before you do something irreversible.
Okay, let's talk about the elephant in the room. We've just made our beautiful old house airtight with caulk and foam and maybe even aero barrier. But now, isn't all the stale old air trapped inside? Isn't this exactly what people were afraid of with the house needs to breathe myth?
That is a completely valid concern, but only if you stop after air sealing. Sealing the envelope is step one, taking control. Step two is non-negotiable in a high-performance home, adding controlled ventilation. You need continuous controlled supply of fresh, filtered air. And the best way to do that is with a balanced system like a heat recovery ventilator and HRV.
And what's the big advantage of an HRV over, say, just cracking a window?
It saves a ton of energy. As the stale warm air is exhausted from the house, it passes through a heat exchange core. It transfers something like 70 to 90% of its heat to the fresh cold air that's being brought in from outside. So in the winter, you get fresh air without throwing away all the money you just spent to heat it. It's essential for health and efficiency.
So at the end of the day, the sources describe this whole process as finding the negotiation space. You probably can't take a 150-year-old house and make it perform like a brand new, super insulated modern home.
And accepting that is the key to a successful project. The goal isn't perfection. It's what the sources call an as low as possible approach. It's a compromise between history, performance, and cost. A good project identifies the low-hanging fruit first, those things like air sealing or attic insulation that give you a huge bang for your buck with very little impact on the stored character.
Yeah.
You don't let a debate over one wall stall the whole project.
That feels like really practical, powerful advice. So to recap the sequence for anyone thinking about this, start with diagnosis, get that blower door test. Then implement air sealing the envelope first approach. And finally, if you tackle solid wall insulation, you have to prioritize those vapor permeable, breathable materials and make sure your team is focused on preserving the character of the home.
Exactly. And maybe let's end with a final thought for you to consider, especially if you're the long-term owner or steward of one of these buildings. When you're planning these retrofits, it's so easy to get caught up in short-term financial returns, a 5 or 10-year payback. But preservation is about making buildings last for centuries. When you model the costs, try to think in terms of very long payback times. A well-maintained, energy-efficient historic home isn't just a house. It's a low-risk, long-term cultural investment. The focus should be on centuries, reinforcing the permanence and the real, enduring value of that heritage.